Okay, today we have a letter from Frank in Frostproof, Florida. Frank writes this: Dear Gary, my propane heater in my Dutch Star does not work. The propane water heater and the stove/oven works, and the refrigerator works, but not my furnace. The electric heat also works. What could be the problem? Well, Frank, typically if you have an issue with just one of the 4 propane burning appliances, that's a big clue right there as to where to start looking. So we can probably focus more on the furnace itself than anything else. But you say it does not work, and I'm not quite sure what that means. Does that mean that the fan comes on but the burner does not ignite? In other words, there's no heat produced? Or when you turn the thermostat on, is there no fan operation whatsoever? So does not work is a little vague to me, so we need to kind of pinpoint that a little bit better. Let's assume that the fan comes on and the burner does not. In other words, there's no heat produced, but you can hear the fan running. That's where we'll end up here in just a second. But there is a common denominator among all the 4 propane burning appliances, and I've mentioned it here many times before, and that is the propane pressure regulator down at the ASME propane container on your motorhome. On that particular, in that particular device, that's what sets the pressure for all the appliances. Now, the fact that you don't have a problem with the other 3 tends me to believe it's probably something interior to the furnace. But you must, to be sure, you must have the propane pressure measured properly by using a water column manometer or some accurate device such as that to make sure that the pressure is being delivered to the appliances at the correct rate. 11.0 inches of water column is what the pressure should be regulated to as it leaves the propane container, goes through the regulator, and then is delivered to the 4 propane burning appliances. So let's assume the pressure is okay. If it's not, I want to make sure you understand that it is time to have it tested or have it measured at least once or twice a year. But looking at the sequence of operation of a typical furnace, here's what actually happens when you close the thermostat or when you turn the thermostat to the desired temperature. Basically, the first thing that happens is that the voltage is being sent directly to some type of a relay to enable the fan to come on. Once that fan motor comes on, that kicks into motion the electric side of the furnace. Now, after that fan picks up speed, there's another device called a sail switch. This is actually also what they call an air prover switch by some suppliers. In other words, the fan has to be moving fast enough in order to make sure there's enough air being delivered into the combustion chamber to support combustion as the fuel is coming in and being consumed by the burner. It sounds a little confusing, but here's the sequence. Once the fan starts spinning fast enough and voltage is allowed to pass through the sail switch, proving we have enough speed of the fan blower, then the voltage is sent basically to the circuit board. Now, the circuit board on the modern furnace performs a bunch of different functions. Number one, it creates the spark that ignites the fuel as it comes in. And in order for that fuel to come in, a gas valve must be opened, and that's another function of the circuit board. It basically provides power to the gas solenoid valve so that the gas can flow into the furnace and into the combustion chamber where it meets that electrode spark, and that's what ignites the burner. And then a third function of the printed circuit board in the furnace is to make sure that the flame indeed stays lit, because if the flame were to go out for whatever reason, and we don't want the gas to be continually pumped into the furnace, so it has a flame sense circuit as well. This is common basically to all brands of electronic furnaces across the board. They all perform this same function. So assuming that we have the fan spinning, first of all, we have to make sure that the fan is spinning fast enough to close the sail switch. Now, here's a picture of a sail switch. You can see it's got a big paddle on one end, basically that grabs the air as the fan moves, blows the air past it, and that simply closes a little micro switch that allows the voltage to continue on to the circuit board. If that fan blades, or if that squirrel cage, if you will, is dirty, take a look at this one. This one is pretty filthy, as you can tell. Dust has accumulated in the blades, and it just simply would not spin fast enough to close the sail switch. Yes, you hear the fan motor running, but it's not running fast enough for the battery voltage to reach the circuit board so that we can then open the gas valve, create the spark, and so on. So you can see how battery voltage is very crucial. That's the other common denominator. That's one of the things that a lot of furnaces are prone to failure, is the fact that it's not being fed enough voltage. Have a technician, or if you have the capability, if you have a meter yourself, you can measure the voltage at the furnace leads where they come into the furnace. Make sure that we have a healthy voltage there. If we have low voltage there, the fan simply can't turn fast enough. If the squirrel cage or the blower assembly itself is filthy, then it would not spin fast enough to close the sail switch. So you have all of these different components in that sequence of operation, any of which could be faulty based on what is happening to it. So we mentioned the relay itself, but I'm assuming the fan motor runs a little bit. So the relay is probably okay. The motor itself is probably okay. If the squirrel cage is dirty, all propane appliances should undergo an annual, what I call a clean and service, whereby the technician disassembles parts of the furnace, cleans it, makes sure that everything is operating properly. The sail switch could be malfunctioning where it's not closing all the way, or it may simply be in an open, constant open situation where the switch will not close. The circuit board, everybody points the finger at the circuit board. Well, typically, I'd say probably 75% of the time it's blamed. It's really not. That's not the fault. Typically, if it's low voltage or dirty components, that's going to eliminate the board from receiving the voltage as it goes through the sail switch and another device called a high limit switch, which is a normally closed switch. This really isn't in your situation a concern because you're not getting heat evidently at all. And then finally, once everything meets at the burner, we got the spark, we got the gas coming in, we've got the right amount of air to be mixed with the flame to support combustion, then we should have ignition of that fire, and then you should be getting heat throughout the coach. So any one of those components, either it could be the motor itself, a dirty squirrel cage, or a fan assembly, could be a faulty sail switch. It could be a faulty limit switch, but that's highly unlikely. Could be a faulty circuit board, but that's kind of unlikely. And it could be the ignition module itself. Take a look at this photo of a furnace ignition module. This is one reason why it's so important to have your appliances cleaned and serviced at least once a year. Take a look at the corrosion and the carbon buildup on the probes of this particular furnace ignition module. If I had to hazard a guess, I would say there'd be more faulty ignition modules causing operator problems than there would be by faulty circuit boards. I think the issue is cleanliness here. Obviously, this electrode would not be able to either create the spark or to monitor the flame. So this, again, stresses the importance of an annual clean and service. So if it hasn't been done in a few years, Frank, I think I'd schedule an appointment to have the furnace cleaned and serviced. Make sure you have healthy voltage coming in, and make sure you get that propane pressure measured. And while you're at that, it's just another simple add-on to make sure that there are no propane leaks anywhere in the system. So that gives you a kind of a rough idea of the typical RV furnace. Most every furnace manufacturer has somewhat of this same sequence of operation, but those are the keys: cleanliness, healthy battery voltage, and the proper amount of propane pressure being fed to each appliance. Frank, I hope this helps.